set of enzymes that all they do are just chop up or break down other enzymes. And these enzymes are called proteases, and they're highly active in different diseases. So if we think about it, let's say cancer, if it needs to spread out from the primary tumor, it needs to actually cut the proteins that are surrounding it. So it uses proteases. So my research is focused on developing new chemical compounds that will actually target different diseases, bind to them, and then enable better detection. My lab focuses on generating compounds that will bind to these proteases, and they will attach things that we can then detect. And then we could use that to learn on proteases, how they're involved in different diseases. And we could also use that for medical uses. So we could actually detect a tumor or different diseases that have these enzymes that are elevated. We use a variety of different methods to see these enzymes. What we did recently, which we are super excited about, is we attached gold particles, so nanoparticles really tiny and then nanometric size, so really, really small, to a little thing that will bind to these enzymes, but only if they're active. So when we put these compounds in the body, they accumulated where there's high levels of these enzymes, and they attached and kept on attaching and accumulating, and we could actually detect that using different methods. And what we recently did was we were able to detect those gold particles with a CT machine. So you don't really use CT for that. You look at the bloodstream, if there's a clot, you could see if there's a fracture, but for molecular imaging, that's really cool. So that was a way for us to detect cancer. Nowadays, when someone goes into the clinic and you wanted to see if he has cancer or so, you do blood tests, and sometimes you take a biopsy out, and oftentimes you do a PET CT. In the world, we have places where they don't have this option. They don't have PET CT. All they have is a CT. CT is commonly used in almost every hospital. I really don't know a hospital that doesn't have a CT machine. So this makes our compounds usable around the world in places where you do not have access to radioactive compounds that need central place for generating that. So we could actually inject these compounds into the bloodstream, and they will circulate. And when they accumulated enough, then we could actually see. So our recent publication is actually seeing like the CT of an animal, you see all the bones, and then you see the tumor covered with gold, and you could actually see it. So that's in the medical field, and this could actually be translated because we could actually use that for people to see where they have small tumors. We combine our chemical skills with actually biological outcomes, and hopefully for the medical field, this could be used in the future.